Welcome to mytutor.ng. In this video, I'll be teaching on the topic electronic configuration. So what is electronic configuration? Electronic configuration describes the arrangement of electrons around the energy level of an atom. An atom is said to contain three subparticles: the proton, the neutron, and the electron. The proton and the neutron resides at the nucleus of an atom, while the electron is found at the electron shell or the energy level of an atom. The way these electrons are arranged is what we are calling what? The electronic configuration. So electronic configuration describes the arrangement of electrons around the energy level of an atom. We say that an atom consists of proton, neutron, and electron. So let's consider this structure. So this is the structure of an atom. Let's call this atom helium atom. The proton and the neutron are found at the nucleus. So this is the nucleus of the atom, and in this nucleus is where you will find the proton and neutron. But the electrons are located around the energy level of an atom. So helium consists of two electrons. So these electrons are found at the energy level. So this is called the energy level of an atom. Or you can also call it the electron shell or the electron orbit. We'll be discussing the types of electronic configuration. There are two types of electronic configuration that we'll be discussing. The first one is called the energy level configuration, and the second one is called the orbital level configuration. So we're going to start with the energy level configuration. So the first type of configuration that we're discussing is the energy level configuration. So the energy level configuration describes the arrangement of electrons around the energy level of an atom. In an atom, there are different energy levels, and each energy level is designated with a number, which we call the principal quantum number. Also, each energy level is also designated with a letter. So in an atom, if this is our atom with the nucleus, the first energy level is designated with the principal quantum number to be equal to n is equal to 1. And this first energy level is also called the K shell. The second energy level is designated with the principal quantum number that n is equal to 2, and is designated with the letter L shell. The third energy level is designated with the quantum number n equal to 3, and is designated with this letter M shell. So this is how the energy level of an atom is being designated, with a principal quantum number. So this will keep going on. The fourth energy level will have the principal quantum number of n to be equal to 4, and is called the N shell. So in this type of configuration, we're discussing how the electrons are arranged around each energy level of an atom. We want to see the arrangement of electrons around each energy level of an atom. To determine the maximum number of electrons that are going to be in a particular energy level, we will use the formula that the maximum number of electrons in a shell is gotten by the formula 2n raised power 2. Remember that our n is called the principal quantum number. So the n is the principal quantum number, and this formula 2n squared will help us to know the maximum number of electrons that will be in a particular shell. So the first shell has the principal quantum number to be equal to 1. Therefore, to get the maximum number of electrons that will be in the first shell, if we use our formula that 2n squared and put the value of n into this formula, that will give us 2 times 1 squared, which will give us 2 times 1, which is equal to 2. So the maximum number of electrons that will be in the first shell is equal to 2 electrons. So we have 2 electrons to be the maximum number of electrons that will be in the first shell. Let's consider the second shell. The second shell has the principal quantum number to be n is equal to 2. Now, if we use our formula that 2n squared, so that will give us 2 times 2 raised power 2, which will be equal to 2 times 4, which is equal to 8. So it means that the second energy level, that is the second shell, will have a maximum of 8 electrons. And that is the reason why when we are drawing an atom, the maximum number of electrons that we'll put in the second shell is 8 electrons. The third energy level, or the third shell, has the principal quantum number to be equal to 3. If we put that into our formula, that will give us 2 times 3 raised power 2, so which will be equal to 2 times 9, which will give us 18 electrons. So it means that in the third energy level, or in the third shell, the maximum number of electrons that will be in that third energy level is 18 electrons. So with this method, you can get the maximum number of electrons that will be in a particular energy level. And this will guide us in writing the energy level configuration. So we are going to see some examples on energy level configuration, how to write the energy level electronic configuration of an atom. So we want to see some examples on how to write the energy level configuration of an atom. So let's consider the first element, or the first atom, to be lithium atom. Lithium has an atomic number of 3, so which means that the number of protons in lithium is equal to 3. And we know that the number of protons is equal to the number of electrons. So meaning that lithium has 3 electrons. So lithium has 3 electrons. Now, if we draw the structure of lithium, the structure of lithium in the first energy level, we know that the maximum number of electrons that will be in the first energy level is 2. So we're going to put 2 electrons in the first energy level, and then if we remove 2 from 3, that will give us 1 as the remainder. So in the second energy level of lithium, we're going to have the remaining 1 electron. So that's the structure of lithium atom, or lithium element. Now, to write the electronic configuration, the energy level configuration will be written based on how the electrons are arranged in these energy levels. In the first energy level, we have 2 electrons, so that will give us 2, comma, and in the second energy level, we have 1 electron, then that will give us 1. So meaning that the energy level configuration for lithium is 2, 1. Let's consider another element called oxygen. Oxygen has atomic number of 8, so which implies that oxygen has 8 electrons. So if we look at the structure of oxygen, the first energy level will have 2 electrons. Now if you remove 2 from 8, the remainder is 6. Now the second energy level is supposed to have maximum of 8 electrons, but what we have remaining is 6 electrons. So that 6 electrons will be distributed around the second energy level of oxygen atom. So that will give us 2, 4, and 6 electrons. So this is now the structure of oxygen atom. Now to write the electronic configuration of oxygen atom, it will be written based on the diagram or the structure of oxygen atom, which implies that the first energy level has 2 electrons and the second energy level has 6 electrons. So meaning that the energy level configuration for oxygen atom is 2, 6. Let's see the third example, chlorine. Chlorine has an atomic number of 17, which implies that chlorine has 17 electrons. Now, if chlorine has 17 electrons, in drawing the structure, the first energy level will have 2 electrons, the second energy level will have 8 electrons, which is the maximum number of electrons that will be in the second shell. Now, so far we have added 10 electrons, so the remaining is 7 electrons. So that means that the third energy level will now have the 7 electrons that is remaining. So this is the structure of chlorine atom. Now to write the energy level configuration, it will now give us the first energy level has 2 electrons, the second energy level has 8 electrons, and the third energy level has 7 electrons. So meaning that the electronic configuration of chlorine is 2, 8, 7. That is how to write the energy level configuration of chlorine atom. So we want to look at the orbital level configuration and how to write the orbital level configuration of atoms. So the second type of configuration that we are discussing is the orbital level configuration. What is an orbital? An orbital is a region of space in an atom where there is a possibility of finding an electron. Now, each energy level is said to contain orbitals. And in an atom, there are 4 different orbitals: the s orbital, the p orbital, the d orbital, and the f orbital. So every atom is said to have 4 different orbitals which can be found in each energy level. The s orbital has only 1 room, and in a room we can only accommodate 2 electrons. A room can only accommodate 2 electrons. So for s orbital has 1 room which can only accommodate 2 electrons. And that is why in s orbital can only take a maximum of 2 electrons, which we write in this form. The 2 is written as a subscript on top of the s orbital. The p orbital has 3 rooms. And if the p orbital has 3 rooms, it means that the p orbital can accommodate a maximum of 6 electrons. Each room having 2 electrons. So that means that the p orbital can take a maximum of 6 electrons. The d orbital has 5 rooms. And that implies that the d orbital can take a maximum of 10 electrons, with each room having 2 electrons. So meaning that the d orbital will have a maximum of 10 electrons. The f orbital has 7 rooms. So the f orbital have a maximum of 7 rooms, and each room will accommodate 2 electrons. So this implies that the f orbital will have a maximum of 14 electrons. So that will give us 2, 4, 6, 8, 10, 12, 14. So the f orbital will take a maximum of 14 electrons. So these are the 4 orbitals that we have in an atom and the maximum number of electrons that are going to be in each of the orbital. The s orbital has a maximum of 2 electrons. The p orbital will have a maximum of 6 electrons. The d orbital will have a maximum of 10 electrons, and the f orbital a maximum of 14 electrons. Now that we have known the different orbitals in an atom, now let's see how to write the orbital configuration of an atom. To write the orbital level configuration, we're going to follow the Auerbach principle. This principle says that the first shell or the first energy level will have only one orbital, and that orbital is 1s orbital. So the first shell will have only one orbital, which is the x orbital, which is written as 1x. The second shell will have 2 orbitals, the x and the p orbital, so which is written as 2x, 2p. The third shell will have 3 orbitals, which is written as 3x, 3p, and 3d. It will not have a 3f. It will only have 3 orbitals, the x, p, and d. The fourth shell will have 4 orbitals, the 4x orbital, the 4p orbital, the 4d orbital, and the 4f orbital. The same goes to the fifth shell. The fifth shell will have the 5x orbital, the 5p orbital, the 5d orbital, and the 5f orbital. Now that we have written out the orbitals that are found in each energy level or each shell, now the Auerbach principle says that we are going to follow a pattern, and that pattern is that we're going to draw an arrow, a diagonal arrow that will cut across each of these orbitals. The first arrow will cut across x orbital. The second diagonal arrow will cut across the 2x orbital. The third will cut across 2p before 3x orbital. The fourth one will cut across 3p and then 4x. The fifth one will cut across 3d, 4x, and 5x orbital. So in that pattern, now once we have drawn the arrow, we will now follow the direction of the arrow to write out the configuration. So from the direction of the arrow, it then means that the first orbital is going to be the 1x orbital. That will be followed by the 2x orbital, because that's the next orbital. The third orbital is going to be the 2p before the 3x, the 2p, the 3x. They are followed by the 3p orbital before the 4x, the 3p, the 4x. Now, if you look at the arrangement, the 4s comes before the 3d orbital, and that is what we call energy crossing, whereby a lower energy level comes before a higher energy level. So which means that after 4s, we will now have the 3d orbital. So after 4s comes the 3d orbital before the 4p orbital, and so on. So there is an energy crossing occurring at 4x and 3d. 4x is a high energy, but it has a low energy, and that is why it comes before the 3d orbital. 3d orbital has a higher energy, so that is what we call energy crossing. And we must make sure that when writing out the orbital configuration, that we do not make the mistake of writing the 3d orbital after we have written 3p. The 4s comes before the 3d orbital. So with this arrangement, we can now write the orbital level configuration of an atom. So we'll see some examples on how to write the orbital level configuration of an atom. So let's see some examples on how to write the orbital level configuration of an atom. So the first atom we're considering is the oxygen atom. the oxygen atom has 8 electrons. So to write the orbital level configuration of oxygen atom, we will first of all write out the orbital configuration or the arrangement, which we know that in the first orbital it will be 1s orbital followed by 2s, 2p, 3s, and so on. Now oxygen has 8 electrons. So the first orbital, which is the s orbital, we know that the s orbital will take a maximum of 2 electrons. So we'll put 2 electrons on the first orbital. Now if we remove 2 from 8, we'll now have 6 to be the remaining number of electrons. The second orbital is the 2s orbital, and the s orbital will also take a maximum of 2 electrons. So far we have added 4 electrons, and the remaining is 4 electrons. Now the p orbital will take a maximum of 6 electrons, and we have 4 electrons remaining. So the 4 electrons will be added on the p orbital. So it means that the orbital level configuration of oxygen atom is 1s2, 2s2, and 2p4. So the 3s will not be included in the orbital level configuration of oxygen. Now let's consider magnesium. Magnesium has an atomic number of 12. So which means that magnesium has 12 electrons. Now, we'll write out the orbital configuration. The first is the 1s, followed by 2s, 2p, 3s, and 3p. So let's stop here. So if magnesium has 12 electrons, the s orbital will take 2, the 2s orbital will take 2, the 2p orbital will take 6 because p take maximum of 6 electrons. So far we have added 10 electrons. That's 2 plus 2 is 4 plus 6 is 10. And if we subtract 10 from 12, that will give us 2 as the remainder. Now it means that the 2 remaining electrons will be added on the 3s orbital. So which means that the orbital level configuration of magnesium is going to be 1s2, 2s2, 2p6, and 3s2. So the 3p will not be included in the orbital level configuration of magnesium. Let's see potassium. Potassium has the atomic number of 19. So it's going to have 19 electrons. Now if you write out the configuration, that will give us 1s, 2s, 2p, 3x, 3p. After 3p, we have 4x before 3d. So that will be the arrangement of the orbital. The 1x will take 2 electrons, the 2x will take 2, the 2p will take 6. We have added 10 electrons so far. The 3x will take 2, the 3p will take 6. So far we have added a total of 18 electrons. 2 plus 2 is 4, plus 6, 10, plus 2, 12, and plus 6, 18. So if we subtract 18 from 19, that will give us 1 electron. So the remaining 1 electron will be added to 4s orbital. So meaning that the orbital level configuration of potassium is 1s2, 2s2, 2p6, 3s2, 3p6, and 4x1. So the 3d will not be included. So this is how to write the orbital level configuration of atom. So we have been able to see how to write the electronic configuration of an atom. Remember we said that we have 2 types of configuration: the energy level configuration and the orbital level configuration. We have seen how to write the energy level configuration, and also we have seen how to write the orbital level configuration of an atom. I believe that by now you should be able to write the configuration of an atom, be it the energy level or the orbital level configuration. So if you have enjoyed this video, please click on the like button and don't forget to subscribe to our YouTube channel to get updates or notification whenever we release our new video. Thank you and see you in our next video.